So here's a bonding and shapes of molecules extension question. You might want to pause it to have a go yourself and then check your answer versus this worked example. So we've got titanium 4 chloride, so the oxidation state of titanium is +4. I'm just going to change to red. So the oxidation state is +4 of titanium and titanium chloride. Shows similarities to group 4 chlorides such as silicon tetrachloride, and that you might know is silicon tetrachloride has a formula such as that. And we need to describe the bonding in our titanium chloride and state and explain the shape of the molecule. Okay, so it implies that our titanium chloride is a molecule. You might think it would be ionic because titanium is a metal and chlorine is a non-metal, but no, quite often you get molecules in this situation. That's what we've got here. Okay, so our formula of our titanium chloride, then if titanium is going to be +4, then we must have 4 chlorines because chlorines is going to be -1. So our formula is going to be TiCl4 of our molecule. So that implies that we've got 4 covalent bonds. All right. So if we're going to start off with describing the bonding, we want to state that there's going to be 4 covalent bonds. But how are we going to get 4 covalent bonds? That implies that we've got 4 unpaired electrons. Yeah, that implies 4 unpaired electrons in our titanium atom. Okay, so let's just check that titanium has got 4 unpaired electrons by looking at its electron structure. So we won't write the whole thing out. Let's refer to a periodic table, and you see titanium's there in period 4, right? So we can start with argon, the electronic structure of argon, plus then we've got 4s2 3d2, yeah, 4s2 3d2, and so we can see that there are not 4 unpaired electrons because the 2 4s electrons are paired up. These 2 3d electrons are going to be in 2 separate orbitals, so they're unpaired. So let's just write that down. So we've got only 2 unpaired electrons. Let's just write it like that, save a little bit of time. Right, so we have to say that an electron from the 4s orbital is promoted. Is promoted to a 3d orbital. It's promoted to a 3d orbital, and now we would have 4 unpaired electrons. So let's put comma giving 4 unpaired electrons. Like so. Okay. Let's add this to make the 4 covalent bonds. The 4 covalent bonds. Let's add that in. Now, now we have to explain the shape. Okay, so the shape is going to be tetrahedral. All right, so let's just write that down. Tetrahedral. The shape is going to be tetrahedral because we've got 4 bonding pairs, 4 bonding pairs of electrons, and no lone pairs. And the bonds are maximally dispersed. Let's say the bonds repel each other. So they can be as far apart as possible. Okay, so that explains the tetrahedral shape. Now we want to explain the fumes. Okay, so fumes we come across a few times in A-level chemistry, and pretty much always it implies this hydrogen chloride present, and that's the case here too. All right, so we're going to notice that it says moist air, so the reaction is clearly between titanium chloride and water. Okay, so let's make a little subtitle for ourselves, fumes, and state that our titanium chloride reacts with water. The fumes are hydrogen chloride. Okay, and why don't we just give the equation to be quite thorough. So we're going to have TlCl4 plus H2O. We know we're going to make hydrogen chloride. We've got 4 chlorines on the left, so we're going to need 4 hydrogen chlorides. We've got 4 hydrogens now on the right, and so we're going to need 2 waters. And our other product is going to be titanium oxide. So titanium is going to stay in oxidation state +4. Oxygen likes to be -2. So we're going to have the formula of TiO2 as our oxide, and as it happens, that's balanced. All right. So I'd say that has most or all of the 8 marks. See what you think.